So what I want you guys to do, go to the CUNY Blackboard, go to our course, and then go to week 13's folder, and then download the dataset CA school that we are familiar with. We already know this dataset, but please download it because we'll use it today. And I'll give you a few moments before you download this, and then we'll start.
Professor, what we have to download this for? What is it for?
Sorry, are you asking why are we downloading this?
Yes, sir.
That's because so we will do certain. We need to run certain regressions, right? So to understand how the joint hypothesis works, how to test a joint hypothesis, we cannot do it like simply on a class slides. I do have examples on the class slides, but I think it's better if you do it in Excel, maybe not.
Okay.
But before I start, so I'm just giving you a few moments to do this, to download this, and then I need to finish chapter 7. Like I'll do it in 10 minutes, and then we'll get more practice using Excel in that. Okay, so how are we doing? So did you guys download this? So I'm also asking you guys to get involved in this in the classes because I think that's beneficial for you, and also it allows me to proceed at the proper pace. So please be involved in class as much as you can try. Now let me share this screen, the blue screen. So let me just remind you. So what was the last class about? The last class was about testing a joint hypothesis, right? And the model is what? The model is yi equals beta 0 plus
Professor, where can you find that at? I'm looking for it. I can't find it.
the data set. So
On Blackboard, week 13.
Sorry?
that's week 13's folder in our course. You will see CA school, Excel file. So do you guys see my blue screen?
Yes.
Yes.
So we might be interested to test the hypothesis about the few parameters. So we might be interested to test, let's say, this hypothesis. Sorry. What is the alternative of this?
Can you repeat the question, Professor?
So I just asked, but I also answered my question. So I asked, what is the alternative of this H null, and the alternative realist is, right? But this is the same as what? As this, right? Sorry.
Sorry, I have one quick question.
Mm-hmm.
Does H alternative imply that only one, either beta 4 or beta 5, are not 0 or beta 12? Could it, like, does it mean that maybe just that all of them are not 0? Like, could H alternative B, beta 4 and beta 5 and beta 12 are not 0.
Good, good. So then you are safe if you write this or and. So exclude all of that kind of possibilities, right?
Makes sense. Thank you.
Right. So it includes like maybe these two aren't 0 and this is 0, right? All of that. So if you write or and, much better. Do you understand?
Yes. Thank you.
But this thing here is the same as what? Is the same as this, right? Do you guys agree with me? I make mistakes. So first, before you answer this way, you need to think, right? And then tell me. Do you agree with me in a statement that they are the same?
Yes.
And you're right. Right now, I did not make a mistake, so it's good. So that's good. So, but so can you tell me how many restrictions do we have here?
Three.
Good. Guys, please be involved. Now I will give you another type of hypothesis. Okay, this will be a little difficult to do, so then I will just do this. So how many? So is this the same as this? Sorry, guys. So are these two equivalent, guys?
No, because the first one, it says beta 4 equals beta 5. It doesn't tell us which value is it. So it can be any value. But on the right one, it says H0 that it's equal to 0. So that's the restrictive. That's at least how I got it.
Good. Now let me ask you, here, how many restrictions do we have?
One.
Good. How many restrictions do we have here?
You have 2.
Good. Um, so this is just one restriction. That involves two parameters, right? Here we have two restrictions. That involve two parameters. That is something that we need to keep in mind. Okay, now let's recall our model. Let's limit k. Let's limit k by 2, guys. Okay. So here, let's say we have only 2 independent variables, right? And then let's say we want to test this hypothesis. How would you test this hypothesis, guys? So we need to transform this model. Let's call this model 1. By adding and subtracting the same term. In this case, it will be adding and subtracting beta 2 times x 1I term on the right hand side of this model. So what do we have then?
BO plus 2B1 X1I.
Yes. Then plus this is what we have right now. We have to rearrange. So let's combine these two terms together and also combine that two terms together. So we will have sorry, it is better if you combine this term with this term, and you will see why, and these terms together. So that will be then yi equals plus, and if you combine this and this, what will you get? I just factored out x1i from these two terms. So are you guys with me?
Yes, Professor.
Okay, so call this Z. Doesn't matter what it is. It's just the sum of, like, you have x2i, here you have the values, you have x1i, you have these values, and then if you sum of those two, then you have zi, which have these values. So that's possible, that's nothing, so that's fine. But look at this. Now, if you test, so you have this model now, because we transformed our model to this one. Now, if you test H null, let me call this gamma. Gamma equals 0. H alternative. Gamma doesn't equal to 0. Is not this the same as H null? So, no, what did I do? It should be equal. That's the new. Can you guys answer? The same, right? Because gamma is what? Gamma is denotes what? So then it is like H null beta 1 minus beta 2 equals 0, and H alternative that beta 1 minus beta 2 doesn't equal to 0. And this is the same as this. So they are equivalent. Okay, so this is how, and then you can use, and in this case, plus we can use simply we call t-test to test the hypothesis that H now beta 1 that's it. So this completes chapter 7, and so chapter 7 done. But now I will give you many examples so that we understand it better. Let's now, I assume, guys, you already downloaded the Excel file, right?
Yes.
Good. So please open Excel file. And
Professor, you mean the cache, right?
I mean yeah, that's CA school.
Okay.
So we already know this data set, right? Because we had examples on this before. So we have these variables here, right? A lot of variables. let's pick a few of them, right? Do this with me, please. So select the following columns.
You see the blue screen, not the Excel file.
Really? But please open the Excel file. I have no idea why this is happening. So today, eyes are zoomed.
I see Excel.
Okay, so then what about now?
Yeah, Excel's good.
So I guys want you to simultaneously do what I do in Excel. So please select the following columns. Teachers, not teachers, no, disregard it. SDR, test score. So if you like click on that, so click on that, and that will select the whole column, then press on control if you have Windows. I'm not sure how to do it in Mac, but if you have Windows, just press control, and then that will allow you to select a few other columns. So then please select test score, column K, and then also select average income, column O. Also select column L, computer expenditures. Also, let's say also meal. Okay. I think that's enough. So
Can you repeat that again, Professor? Oh, I see. Hold up. I see what you follow you. Okay, it's okay. I got it.
good. So now just copy all of these guys. And then open, do you see this plus here? Open a new worksheet, and then just paste those there.
How can you do that, Professor?
Just copy, Control C, copy, and then you just you will,
Control P.
and then you press plus here, and then you will just Control V, that will paste.
Okay.
Professor, does the order matter?
Order matters because if you want the results to be to coincide my results with my results, then you have to keep the order. But I want to reorder these. So, but it doesn't really matter. That's okay. So now I want you guys to open R. Okay. Or maybe I can do this in Excel for now. Okay, let's do this in Excel. Okay, let's do this in Excel first, and then let's do this in R. So up until now, guys, you should be like, you should already have to, I mean, you should have prepared your data, which is like, do you see my Excel file?
Yes.
That's what you are supposed to have right now. Okay. Now let's go to data and then data analysis. And let's choose regression. And then okay. Now we'll have to input Y range, which is what? Y is the dependent variable. So the dependent variable is test score. So please select not the whole column, but the column that includes the label, test score, and also the data values.
I'm sorry, which data analysis tool are you using again? Regression.
Yes, yes.
Professor, which one you add in there in the y-axis?
Test score.
Okay,
That's
B1 to 421.
which
Okay.
is the second, I think, second column.
Okay.
Now, what I want you guys to do, let's disregard this mil PCT. I don't think that's very important. And let's select as independent variables, let's select the remaining 4 columns except column A. So there will be these 4 columns. I will input all of this data and this information in the X range. And
Professor, you took C and F all the way. Okay, I see. Okay, I'm sorry.
that's okay, that's fine. So, but so now, guys, please select labels, check labels, because we already selected the labels, right? When selecting the data. And then click OK. So do you follow?
No, 1 second, Professor. Give me a second.
Sure,
I lost you.
that's fine. Try to do it.
Test scores. The computer messed up on me. Okay. And then we're gonna do C. Okay. All right, we're good to go.
How about you guys, others? So if you are, if you already have this done, then just click OK, and that will give us the results.
It's not showing anything. It's saying X range and Y range must have same numbers and rows.
That's because you probably did not select the variables well,
The variables.
the data set. So
I did test scores for input Y range all the way to 1 to 421, and then I did C all the way to F. Okay, I see. Yes, I think I did. Yeah, C2.
yes, please. So you need to be
I
careful.
said C2, right? Okay. And B2. Okay, let's see what happens now. No. Professor, did you did it from the number 1 to 421, or you did it from 2 to
No, from 1 to 421. But then you need to also select labels.
the label? Still giving the same. All right, so let me do this again. You said test scores, correct?
Yes, let me do it again. So go to data analysis, and then regression, okay. And then, do you see my screen?
Uh-huh, yeah,
That's what I have here.
okay.
B1, B421, C1, F421, and
Let me do the other one now. Okay.
then
Now I got C1 F421 too.
yes, and then also please check labels, and then if you click OK, it should work, because that's the only thing I
I'm
did.
trying to type the formula. I don't know. It's not working.
Okay, so that
No, it's not working. It's not working. Let me do this again real quick. C1 all the way to okay, 421. Let's see. Okay, it worked now.
good. So now we are fine. So this will be our unrestricted model. This will be like, what will be? This will be like y equals, do you see my Excel?
Yeah.
Beta hat 0, 0 plus beta hat 1 times what? Com STU plus beta hat 2 times X and STU plus beta hat 3 times STR plus beta hat 4 times average income.
Do we have to copy that, Professor? Was you writing?
No.
We have to do the beta too?
So I wrote it and now something happened. So what is this? Okay, so let me copy this. Take cut middle here. So this is our model, guys. Just want to. This is the estimated model. This is like estimated restricted model. Sorry, unrestricted model. Right? But let's say we want to test the hypothesis that H null is what? H null, let's say, is that beta 2 equals 0 and beta 4 equals 0. That's what I want to test. H alternative is that beta 2 is not 0 or and beta 4 not 0. Guys, do you see my Excel file?
Yes.
So we will need, for this, we will need what? R squared unrestricted. Do we have this number? Yes, because we
Yes.
estimated this model is not adjusted R squared, guys, but R squared. We have this number, right? So that's this. But do we have R squared restricted? Okay, what will be our restricted model? A restricted model will be what, guys? There will be y equals beta 0 plus, can you help me?
Is that no?
Are you just including the betas and not the intercept?
I'm just including those betas that are not 0. So H null restricts beta 2 and beta 4 to be 0. So they will be those will not be part of the restricted model. Okay, so what did I do?
So are you only including betas 1 and 3
Exactly.
and beta 0, right? Intercept.
Because beta 2 and beta 4 are zeros. That's it. It's the H null hypothesis. Beta 1 is convex TU, beta 3 is SDR. Plus the disturbance term U. So this is the true restricted model, right? Do we have estimates of beta 0, beta 1, and beta 3 from this restricted model?
Yes.
No, we don't. Did we run a model on only on
Uh,
CompSST and SDR? No, we have to do it right now.
so the coefficients aren't the estimates?
No, it is the coefficients for this model. For this model are not here because we did not run our Y on comp STU and SDR, right? So we will do it right now. So now we will have to do it right now. So go to the data set that we have. You see my Excel file, right? And then go to data,
Yes.
go to data analysis, select regression, okay. And now the dependent variable is fine. So this part is okay, but we have to select this part, right? The independent variables. But as you guys see, if you notice, so here, I'm not sure if it allows us to do it. Like we have to select this, and also we have to select this column, and maybe I can say comma, and I will also select this column. Okay. Did it do anything? Something is wrong here.
Professor, are you just selecting betas 0, 1, and 3?
No, I'm just selecting columns for column C and column E because those are part of the model. And the problem is that they are not like in between C and D. Column C and D, we have this column D, right? So I'm not sure if it allows us to. I'm not sure if it allows us to do this.
So column C and E are part of the restricted model or part of the test? Like it's what we're testing.
Part of the restricted model. They are part of the restricted model because,
Okay.
right? I'm just checking something. And, comma. Sorry guys, I'm just checking something. Column C, let's say this. Well, if it lets me to do this. No, it doesn't. So the thing is, guys, there's no other way to do it. So please follow. So when we select the range of independent variables, the variables should not have anything in between, right? So here we see that I want to select column C and column E, but in between those two columns, I have column D that should not be there, right? So guys, are you with me?
Professor, you can't use the comma. Does that not work?
It does not work. No, it did not work for me. Did it work for you?
No.
Yeah, so we have to do, this is a limitation of Excel. In R, we don't face this kind of problems. So what I will do right now is that I will just delete column D or you can just, yeah, so let me just delete column D. Right, and there will be no column D, and there I will just have these two, right? Nothing in between, right? Comp STU and STR. Do the same thing, please. And then go to data, and then go to data analysis, and then regression. Y range is fine. We just need to adjust the X range. Now I can select these together, okay? And then you just click OK. And that's the results, okay? Do you have these results?
Yes.
Good. Let me copy this. Please copy all of that and put it in this worksheet, like the one that we had from before. Right? Let me do this in a different color. Visible, which is better? This one. There we have this. Okay, do you guys see? I don't need this as well. Okay, so this model only includes these two variables, right? So this model, these estimation results correspond to this true model. Do you see what I mean? So
Yes.
therefore, what will be R squared restricted?
0.095.
5.
This one, right? That will be the R squared restricted. Now we need to recall the formula of the F statistic. If you guys go back to the last class slides, you will see that there you have the formula for the F statistic. And F statistic is what? F stat, which will be here, equals what? And let me do it here. Something divided by something, but that something also has something divided by something. And in the numerator also we have something divided by something. What do we have here? R squared unrestricted minus R squared restricted. So which is R squared unrestricted is this minus R squared restricted is that. And you have to divide it, sorry, this one. And you have to divide it by what? Do you remember? Number of restrictions, which is what? In this case, what is number of restrictions, guys?
Is it 3?
No, look at the H now.
Oh, it's 2, right?
2.
Yeah. And then we have here 1 minus R squared unrestricted, which is what? This one. And then you have divided by what? N minus K minus 1. N is number of observations, which is this one, minus what is K? Can you tell me?
It's a number of independent variables. I think it was like 6 that you selected.
A number
Or
of
I forget.
number of independent variables where? Can you tell me? In the unrestricted model or in the restricted model?
The unrestricted.
Four.
Exactly. So then look at the unrestricted model and how many independent variables do we have?
Oh, it's 4.
Good. And then minus 1, that 1 stands for the intercept. And that will give us what? F statistic, which is this, right?
56, 197. Yeah.
So, but then we need to compare this to the F critical, right? Right. How do we obtain F critical?
Sorry, what is it divided by again for F stat? What do we divide by?
You can take a look at this formula, but it's what? It's 1 minus M7. M7 is R squared unrestricted. Divided by B8 is number of observations, 420, which is the same for the two models. And then minus 4 is the number of independent variables in the unrestricted model, and the minus 1 stands for the intercept. Okay, now we have to now see what's the F critical. For F critical, we need to know the numerator, degrees of freedom, and we also need to know the degrees of freedom. I said before that the numerator degrees of freedom is the number of restrictions, which is in this case 2. What's the denominator degrees of freedom? That's n minus k minus 1. In this case, it's 420. So it's 420 minus k. K is 4 minus 1. That's 415. So now we are ready to go to the table. And also, if remember, if the denominator degrees of freedom is greater than 120, we use page 1 of F table. Otherwise, use other pages. So let's open this table. This is the F table, guys. It is already uploaded on the Kine Blackboard. And I hope now you see. Sorry, I just. Do you now see the F table?
Yes.
Good. So this is the page 1 of F table. You see here F M infinity, that stands for the situation when the denominator degrees of freedom is greater than 120. So in this case, in our case, that's the case. So so we will be using this first page of this table. What did I do? Let's test this hypothesis about at the 5% significance level here. So we are in this column, and the numerator degrees of freedom is given in this column. How many? So numerator degrees of freedom is also coincides with the number of restrictions, right? So we have 2 restrictions. So we are in this row, right? But also we are, sorry. We are in this row, but also we are in this column. So what is the critical value for that stat?
3.
Exactly. So that means so here we have 3. So then we have this situation, right? Which means reject age null. So that means what? Thus, guys, do you see the Excel file?
Yes.
Yes.
So this means that we rejected the age null. That means at least, based on the data that we have, based on the, we are 95% confident because the significance level was is 5%. So that means based on the data we have, we are under certain assumptions that we have, right? The either beta 2 is not 0 or and beta 4 is not 0. So that means that beta 2 and beta 4 are jointly significant. That's the answer to this. So guys, so I will upload this Excel on the Kine Blackboard. I will right. You will also have this recording, and you will also do the exercises yourselves because the homeworks will have exercises on this, right? So you'll get more practice. But this is pretty much it. So this is how you do this in Excel.
Quick question. How
Sure.
do we know to reject the F stat when comparing it to the F critical? Is it when the F stat is bigger than the F critical?
Exactly. So if you look at this, share a different screen. If you look at this F table, if you look at this F table, we see what? Do you see the F table?
Yes.
So the rejection region is in this blue area. The rejection region is the area above the critical value, right? In our case, the critical value is 3. So 3 is here, and 190 something is above. Much.
So,
Then
okay,
that's
so
right. So that's also note that F stat does not ever take the negative values. It's always positive. Okay, good. Now let's see if we have in Excel if we have this function for F distribution.
Professor?
Yes.
So is the rejection rules the same as the ones we used previously, where we have the Z critical, the test stat?
The logic is the same. The intuition is the same. But the thing is, the critical value will be, the number will be different.
Yeah.
That's why we have, the number will be different. That's why we have all these different tables, right?
Okay. So, for example, if the test stat is bigger than the critical value of the level of significance of alpha, we would reject.
We always reject H null if the F statistic is greater than the critical value at the significance level in consideration.
Okay.
Okay. Now we need to look at the 0.05 degrees of freedom is 2, and then here we have 120, right? And that gives us okay, this. This should work. I don't know why. Which one's the inverse of the left probability distribution? Yeah, so that's what I want. Yes. Oh, okay, okay, no. This is what we want, the white tail. It's fine. It's the white tail. Probability in our case is 5% significance level, 0.05. That's it. So we have 2. We have then 4. So degrees of freedom, the numerator degrees of freedom is 415, right? Okay, cool. And then, so which is very close, right? So do you see, guys? Guys, are you here? I simply wanted to let you know how to do this in Excel, which gives you a very precise answer.
We still see the F stat table.
Oh, really? Okay, so the F stat gives us this value, right? 3.
Yeah.
And then that at 5% significance level, but that's not precise, right? If you want to get the precise answer in Excel, then let me share the screen. So then what you do is that equals F this RT. RT stands for the right tail. Sorry, not this, F inverse right tail. And then here you write what? You write that the significance level is 5%, 0.05 then, comma, the numerator degrees of freedom here is 2, and the denominator degrees of freedom is 415. Do you see, guys?
Yes.
That will give us the critical value for the right-tailed F test, right-tailed F distribution test at 5%. That's why I wrote 0.05 here. If you wanted to at 1%, then you would write 0.01. And you get 3.0117. Okay, that's pretty close to 3, which is from the table, right? Do you guys see what I mean? But this is the precise for answer. So the tables are never precise. If you want to get the precise answers, then please use Excel or maybe R.
Professor,
Yes.
so is this the type of questions that are in chapter 7, like on Pearson?
Yes. There are these questions are, of course, similar questions are obvious.
So would this be like the empirical question, or would this be the analytical question?
Could be analytical as well, but in most of the times the F table will work. But if you want to get the precise answer, then you will need to use either Excel or R, for example. Do you understand what I did?
Yeah, I just want to know if like this is like we would have to do all this to solve like a chapter 7. Like,
You will have
question.
to develop. You will get more practice. Yes, you will have a lot of questions.
Okay. All right.
But this is the function, guys. To obtain the F critical, that's what you do. That's what you write in Excel. Here, 0.05 stands for the 5% significance level. As I said, if you want, let's say, 10% significance level, then you would instead write 0.10, right? And then this 2 is the number of restrictions, or the denominator degrees of freedom. For 15 is the number of, the denominator, I missed that. So 2 is number of restrictions, or the numerator degrees of freedom. For 15 is the number of, the denominator degrees of freedom, which is n minus k minus 1. Am I clear?
Yes.
And this 3.017 is like if you round it up until like this, even like the first decimal, then it's 3, which is what we get from the table. But if you want to get the precise answer, then please use the Excel. That's what I want to say. Right? And okay, so that's it. So I think that's pretty much it for today. Let me just double check everything. Let me double check that I explained everything I wanted to explain. Looks like I did. So I will just let you know what we will do next time. First of all, you'll get assignments on this chapter. I will assign chapter 7 homework assignments today. Next week, I will not explain a new chapter. I will do exercises from chapter 7, and also I'll do some Excel and R stuff. So I will give you more practice how to perform all these things in Excel and in R. So that's the plan. And in 1 week, a week after, I will explain chapter 8. So that's the plan. So guys, do you have any other questions? Any other questions? Please let me know. Do you have any concerns, any questions, anything? Because I think today's class is pretty much this.
Yeah, Professor. So essentially this chapter is like to solve any question, it's all done through Excel or R.
Yeah, pretty much.
Okay. All right.
Okay, guys, if you don't have any more questions, but if you have, please ask. If you don't have, then maybe I can finish today's class.
Last question. Sorry,
Sure.
Professor.
Yes, fine.
Would it be faster to use R than Excel?
I will show how to do all of this in R, guys. I don't really have time for that. If I start, then I'll have to do like it. I will need more time, right?
Yeah.
5 minutes will not be enough. So, but I mean, R is quicker. R is much quicker than Excel.
All right.
I mean, Excel is also fine, but if you know both, much better.
All right. Thank you.
No problem. Okay, guys, then I wish you a good weekend. Have a nice day. Have a good weekend, and I'll see you next Monday.
Thank you. Have a great weekend.
Very
Thank you,
Eureka.
Bye.
Professor. Bye.
Bye, guys. Thank you very much.